So now, therefore, this is as a result of this being being added with ethene to form this thing. How together? So this now becomes polymer. Polymer. And it is what we call, when you want to call this one, you call it polyethene, which we commonly call it polythene. So this is a particular molecular structure or structural formula used in producing polythene bag. So JAMB will now ask you, what do they use in production of polythene bag? This structure being drawn is for the production of polythene bag. Dash, then you put the correct answer. So this is that under polymerization. So now let me still put another one. Polyfine chloride. Polyfine chloride. Polyfine chloride is all you need to do is that you just erase this, put chlorine, erase this, put chlorine. How we? So this is fine chloride. So you can still add another more. This, put chlorine, put hydrogen. So then when you add them together, so polyfine chloride, this is also this is fine chloride, fine chloride, the addition of them, it becomes polyfine chloride, PVC, which is used in production of ties, pipe, and so many things. And what is the question that will ask you there? That the PVC is used in production of what? A, is it for the production of plastic, pipe, and others? B, production, the word should come to your mind, it is plastic, pipe, rubbers, and so many things. It is one of the uses of Alkene. Now all you need to do, you do the same thing. How many? 1, 2, 3, 4, 5, 6. Put 6. Carbon 6. 1, 2, 3, 4, 5, 6. Then what are we having? Hydrogen. Put hydrogen. Then this is chlorine. Put chlorine. Hydrogen, chlorine. Put chlorine. Hydrogen, put chlorine. So this is hydrogen, 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 this is hydrogen. So now this is what we know as, if they ask you, JAMB will now ask you another question that they might ask you here. That this particular, this is unsaturated, this is unsaturated, this is unsaturated, to become a saturated compound as a result of single bond. Now JAMB will now ask you, they can draw this structure. They will now say, name this structure, or this, what is the IUPAC name of this structure? It is the common IUPAC name of this structure. It is what? It is PVC, which we all call poly. This is monomer. When they add them together, become polyfine chloride, which is used for the production of plastic, rubber, ties, and so many things. So that is that under that. But if they ask you to name it normally, now the next thing is uses. We have done with chemical properties of alkenes. Please try and read more, and the review question that I've stated out, please try and check more. Go deep in. These are all. What JAMB need is your understanding. What you have comprehended from the SSC program, that they want to test your IQ. It's very easy. The question is cheap and very easy once you understand it. That is why I'm explaining it in total. Now, use of alkenes. Number one common uses of alkene, and the JAMB do ask. I'll be bringing down some question now that it will be serving as a reference to it. Number one, it is used as a ripening fruit. It is used as an agent in ripening of fruit. It is used in ripening of fruit, or it is used as an hasting in ripening of fruit. So they use ENE. They use it when they want to, when the unripe something is there, you can use it and it becomes ripe. Now that's number one uses of what? ENE. Number two, it is used in production of PVC. I've explained it earlier during the chemical properties of ENE. It is used in production of PVC. So JAMB will ask you, which alkenes happens to be an organic compound. It is used for one of these uses. A, used as an organic fuel. B, used in production of PVC. C, used as a drying agent or dehydrating agent. What should come to your mind? It is used as a what? A material used in production of PVC, polyfine chloride. It is also used, number 3 uses, it is also used in production of polythene bag. That polythene sack bag that you use, they also use it in production of this. So they can ask you, that happens to be one of the material used in production of sack bag. The ENE, that alkenes is one of them. Are we together? So these are all the uses that we have to state there. Now let's go to the laboratory preparation of ENE. It is a common question that JAMB do ask. Now, what are the 2 questions that they will ask in laboratory preparation, or more than 3 questions? They will ask, what is the catalyst used? 1. Then number 2, what it is done at what temperature? Now, so we are under laboratory preparation of alkenes. They do ask as well. Please note all these things that I'm asking you. If you go and check your series, you'll be seeing all what I'm saying. I'm just summarizing everything. Now, laboratory preparation, you don't cram anything. The laboratory preparation of alkenes, they will ask you, what is this catalyst used in preparing alkenes? I will tell you the catalyst. Then number 2, what is the compound used in preparing alkenes? I will tell you that. Then number 3, what is this occur at what temperature? At what temperature? I will tell you at what temperature that these are the questions that they will likely what ask you. Then what are the product form as a result of what? As a result of the dehydrating of the reactants. What are the products that will be formed? So these are the questions that they will likely ask you. Now let me see C2H5OH to form. This is ethanol. This is ethanol. The dehydration of ethanol. This is ethanol. The combination of C2H5 is ethyl, ROH. Then ROH is what we know as what? Ethanol. ROH is what we know as what? Ethanol, which is alkanol. This ethanol, the dehydration of ethanol using a concentrated tetrahydrosulfate 6 acid. The dehydration of ethanol, alkanol, using a concentrated tetrahydrosulfate 6 acid is what we know as laboratory preparation of what? Alkenes. What do I mean by that? When they say in chemistry, when they say dehydrating, even normal English, when I said I'm feeling dehydrated, meaning I need water as a chemistry student or as a science student. So when the dehydrating, when they say hydrating, when you add water, addition of water. But when they say dehydrating, the removal of water, the dehydrating of ethanol or alkanol. So the dehydrating of this ethanol, the removal of water from this ethanol is what we form ENE, alkenes. Are we together? All you need to cram here is that the dehydration of alkanol lead to the production of alkenes. So they can ask you, dash, the dehydration of alkanol result into what laboratory preparation? The dehydration of alkanol result into what laboratory preparation? Is it alkane, alkenes, alkyne, alkanol? Don't think of anything. It is what? Alkenes. How do we do that? So I'll pick ethanol. So when you dehydrate it, that means minus H2O when you remove water from it. At what catalyst? I've mentioned it. Conc H2SO4. That is the catalyst. So JAMB, we still ask you another second question. What is the catalyst used in doing the laboratory preparation of alkenes? It is concentrated tetrahydrosulfate 6 acid. Then they will still ask you, at what temperature? Just tell them at 1. They will not bring it. At what temperature? They will put 120 degree, 300 degrees C, or will come to your mind. You go for 180 degrees C, 180 degrees Celsius. So now that means when you add this to this one, water will come out. It's very simple. Water is what? H2O. This is how many H? This is H5 plus 1H, H6. Remove 2 from it. Remain what? H4. It will now be C2H4 plus the 2H that I removed. So therefore, when you add concentrated tetraoxosulfate acid into this one, there will be removal of water. Now, what are the questions? I've mentioned more than 2 to 3 questions. The catalyst involved is concentrated tetraoxosulfate acid. So they will ask you what catalyst involved during the preparation of alkenes. A. Concentrated HNO3. B. Concentrated H2SO4 and many more. Go for this. Then it boil at what, or it happen at what temperature? At 180 degree temperature. Now, 18. We have gotten 18. Now, this is how many hydrogen? 6. So that means we will remove 2 from it. That is why we arrive at H4. Then that 2, put it here, is because the bond is not that enough. That H2 that we remove from, this is 5, this is 1, 6. We have removed 2 there to form water. We are removing water. That is it. So H2. Then the O that is here, put it here. Now, what are we left with? We are left with 18 and what? And water. Are we together? So this is how we prepare alkenes in the lab. Are we together? So they can ask you another last question that they can ask here, that what form only 2 products? Then the 2 products are ENE and water. What form 2 products? And the 2 products are ENE and water. That means alkenes and water. It is laboratory preparation of what? Of alkenes. And another thing, what form ENE and water as a result of what? As a result of dehydrating of what? What form ENE and water as a result of dehydrating of what? That means what form this product, ENE, ethene and water, as a result of what are they dehydrating? A. Alkanol. Is it alkanol they are dehydrating? B. Alkanate. C. Alkanoic. What should be your answer? Alkanol, which is ethanol, butanol, propanol, methanol, and etc. Are we together? That is that under that. These are the likely questions they can ask regarding that. The next one that I'll be showing you is the nomenclature. That is the main bone of contention. So there where I'll be reviewing some past questions regarding that. So I won't state any rules. Now, the nomenclature, that is the last aspect of this topic. The nomenclature of what? Of alkenes. Please go and watch our video on general naming under alkene. The same rule, the same rule also apply to this one. Have we? So if you check our nomenclature of alkene, how to name, then you will know what I'm actually saying. So go and visit our site and know how to name nomenclature of alkene. We give you an into nomenclature of what? Alkenes. Are we together? So let me be reviewing some past questions under JAM, then we are going to be naming them. Now this is one structural formula for ENE. How do we know that it is ENE? Check, there's double bond here. Then let's quickly go straight to the point. Firstly, you have to determine the longest chain. Go and read more on that. We have done a video that will tell you the rules guiding this. Now how to, is either you can't like this, you can't like this, can't like this, can't like this, or you can't like this. So what are we counting? The carbon. Are we together? So now let's count. This is carbon. 1, 2, 3, 4, 5, 6. If we count like this, it is 6, which is X. X what? It will be X in, something of that. So now, that means we have X there. Now, if we actually count like this one, from this second one, it is 1, 2, 3, 4, 5. That means this is greater than this. You can't. What of this? 1, 2, 3, 4, 5. Are we? This one is also greater than. What of like this? 1, 2, 3. It is also greater than. What of like this? 1, 2, 3. It is also greater than. That means the longest chain is from here. So, and which is X. X, something of in. So, what is the in that we want to? So, after we finish naming all these things, we are going to put in there. So, now know that since we are starting from here, 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6. As a result of it is the longest chain. This carbon that we are not counting, this carbon that we are not counting, they become the substituents or branches. That means they become the children. That's what we mean. So that this is methyl, this is also methyl. So since we are not counting it as the family name, as the longest chain, you classify them as the substituent. So if I ask you how many substituents do we have? 1, 2, 3, 4. So chlorine, our family of halogen, and our key group, these are the substituents. Then what follows? The next thing that follows is that all you need to do is that you check the position of the double bond. The double bond, is it closer to this side or to this side? And check, this is chlorine, this is methyl. Alphabetically, chlorine comes first before methyl. C comes before N. So now you check where the double bond is, the closest carbon to which is, and also to the first substituent that you have to firstly note, which is the chlorine. Now let's check. If I have to count like this, 1, 2, 3, 4, the double bond fall on carbon number 4. Then the chlorine also 1, 2, 3, 4 fall on this. But if we start from this 1, 2, 3, see the double bond fall on carbon number 3. That means the double bond is closer to this carbon. And also check 1, 2, 3. This double bond is also closer to this chlorine. So you start counting from this. Are we together? Now note that the first thing to do, so we can't count like this, because the position of the double bond here is larger than the position of the double bond here. The double bond is closer to this and also closer to the what? To the branches or the substituent. The next thing to do is that we have 1, 2, which is 2, comma, because we have 2 chlorine. 1, 2, 2, comma. Since it is number to number, we still have another chlorine here. We want 2, 1, 2, 2 chloro. 1, 2, 3. Another chlorine. You will now say 2, 3. So that means chlorine, first chlorine was found in carbon number 2. The second was found in carbon number 3. 2, 3. Is there any chlorine again? No. 2, 3. Iodine, dichloro. Are we? So that has gone. Remain how many substituents? This and this. This is not one of them because we count it as the longest chain. So which is, whatever you start, from the position you start, you can't go to another side. You continue from that, which is 1, 2, 3, 4. What would that be? Iodine again. 4, comma. We see methyl here. We still see methyl here in carbon number 4. 4, comma 4. How many methyl is that? Dimethyl. Then, is there any more substituent? No, you can't count this as the substituent because it has been the family name. So, then what follows? The next thing is to run. Since there is no more substituent, the next thing is to run the eggs, 1, 2. This in fall on carbon number 2. This double bond fall on carbon number 2. You will now say eggs 2 in. This is the answer. So, this is a jam question, question number 41, 2008. This structure, what is the IUPAC name of this? What will be the correct answer now? It is option number C, 2, 3 dichloro, 4, 4 dimethyl, X2A. Are we together? So that is that under that. That is that under that. Hussein, that is that under that. Let's say another question. Now, this is another question, 2006, question number 26. 2-methyl but 2-ene has the structure of what? Is it this one? Is it this one? Is it this one? That means it has the structural formula of what? All you need to do, forget about this answer. You do yours first. Firstly, put this, but 2-ene. That means we have what? How many carbon? 4 carbon, which is C, 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 C. Then 2-ene, that means that the position of ene is on what? Double bond is on what carbon? Carbon number 2, 1, 2. Put it here like this. Are we? Now, 2-methyl, but that means I will start from here. Because, you know, I told you, we'll be checking the position of the ene. 1, 2, 1, 2. So if I start from any other side, in order for me to put my substituent, there is no problem. So 1, 2. What we have, I can put what here? I can put methyl here, which is CH3. Now, this is this. Now, look at this. 1, 2. 2 methyl. 1, 2, 3, 4. You know, if you count like this, 1, 2, 3, 4, it's still the same thing. 1, 2, 3, 1, 2, 3. 1, 2, 3, 4. What they want us to do, boot 2 in. This is boot 2 in. On what? The methyl is on carbon number what? Number 2. 1, 2. 2 methyl. 2 methyl, boot what? Boot. This is 1, 2, 3, 4. Boot 2 in. Are we together? So therefore, let's check. We are the one that put this. I told you that firstly what you come to your mind is boot 2 in, which is carbon, 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 4 carbon. That in is on carbon number 2, which is what I put here. Though the next thing is to put methyl here. Let's see, 1, 2, 2 methyl, cause in fall on this. And if you start like this, they are on the same position. In also fall on carbon number 2. If you start from this, also fall on carbon number 2. So this is 2 methyl now, boot what? Boot 2 in. Are we together? Even if you are counting like this, 1, 2, 3, 4, it's still the same thing. 1, 2. You can see this becomes the substituent. 2 methyl again. The in is on number 2. 2 methyl, boot 2 in. If you are counting like this. So if you are counting like this, but don't make things more complicated for yourself. Always go straight like this. But if you still bend like this, since they have the same longest chain, this also 1, 2, 3, 4. Boot 2 in. This also boot 2 in. So you use the straight chain. Are we? Now let's see 1, 2. 2 methyl. Then boot. Then the in for double bond fall on carbon number 2. This is it. Then let's check the correct option here. The correct option is C. How is it C? Don't be scared. They digested this to be C. How many hydrogen? 1, 2, 3. That is why they put 3 here. Then carbon. How many hydrogen here? 1. You can see the physical hydrogen is 1. You put 1 here. Then the double bond. This is double bond. So what follows? We have C. Then the methyl. This is CH3. Are we together? Then another one here, which is C. How many hydrogen? 2. Then put 2 here. So the correct option is it is C. It is C. Hope you get what I'm saying. So that is that on that. So correct answer is C.